Welcome to the future of flight, and I hope that you are sitting comfortably as we begin this keynote. I'm Paul Perera. I'm looking after the technology team of GKN Aerospace, and I'm going to talk to you today about three things: sustainable aviation, accelerating that innovation, and improving our ways of working through Industry 4. I hope this presentation gives you about 20 minutes of food for thought, starting with a bit of introduction to the company, and then I'll take you through the journey of what my sense of purpose is, and really delighted to be here with you, with the Kenyan team from the IEEE in Africa, and working with you to help define the future and the purpose that you might have in your careers in engineering.
You know that feeling? The plane gathering speed, the wheels on the tarmac, and then takeoff. And it gets you every time. We make that feeling. You know that feeling when something just works with precision, power, and control. You know when you're part of something big, creating something amazing, thinking globally, forging partnerships, improving performance, increasing efficiency, touching every aspect of the aircraft. That's who we are. You know that feeling when you're just up there and everything just seems perfect. That's what we do. Together, we make it happen.
Well, we make it happen, and we're going to make it happen today, talking about these three things. So firstly, we're going to talk about what we mean by sustainable aviation. Second, we're going to talk about accelerating innovation, and then we're going to talk about Industry 4. So I hope that you're strapped in, ready for the ride, and enjoying this experience of being in this collaborative environment, which is actually GKN's new Global Technology Centre. We'll talk more about that later. So sustainable aviation, why? Why are we talking about that today? It's more important than ever that we think about listening to these people, the kids and generation that becomes the future, and they're telling us, in Greta Thunberg's words, to listen to the scientists. So why? Why would we do that? Because we believe that our future is going to be destined to more than just coronavirus and COVID-19 that we're facing today, but many more people will die. Then sadly they've died already because of climate change. And climate change is upon us, and we can see that in everything that we're doing. Ed Hawkins here from Reading University in the UK has defined that between 1850 and 2018 we have seen the planet's temperature rising beyond all measures. And here we have a visual representation of how those temperatures have risen in those years. So the longer that we leave it, the more it's going to impact on us. So let's show our stripes, let's show what we believe in. This is where I live, in Bristol in the UK, and clearly the temperatures here have just gone through the roof in my years of being on this planet, and we need to look at what we can do differently. So we are looking at the biggest risks of the environment according to the World Economic Forum in 2019, where they really highlighted 5 areas which all come back to the climate, weather events extremely likely to happen. We're seeing some of those even earlier this year in Australia, in India, and we've seen the climate mitigation, adaptation, natural disasters. We've seen man-made environmental disasters and biodiversity loss and ecosystem collapse. I'm sure in Africa many of those things are visible to you as well. And we need to avoid those likelihoods increasing. Of course, one that didn't appear on there was COVID and the pandemics. But if you look at the next slide, it appears at the bottom, has a massive impact. But maybe a bigger impact today and a higher likelihood than all of that is climate change. As I look to those areas which we've just talked about and think about how they're positioned, if COVID was bad, the climate crisis is worse. And sustainable aviation is important for one reason. It's part of the contributing factors to CO2 and other carbon issues related to greenhouse effect, but also has an impact on the way that we will either survive in this planet or die on this planet. And that's the serious part of this slide. The longer we leave it to tackle the challenge of 2050, which is what we've given ourselves as our goal of becoming less than carbon neutral, but actually taking ourselves below the 2005 carbon figures, where aviation growth is taking us in the wrong direction, something has to come along, whether it be technology we have in our hands today or something more radical to change the curve. Otherwise we're heading in that red zone and heading up into an area where more people sadly will lose their lives. And that's where we've got to think differently in aviation and in other carbon-based fuels, and looking at the alternatives. Otherwise there's another way to do it, just to tax everyone economically, just make it impossible to see yourself flying. And we can't afford, in this kind of world which is very globally connected, where we look at building relationships, to rely on purely electronic means to communicate. We have to see each other face to face, we have to meet and greet, we have to be there in the presence of others. And what do we think is the solution? Well, we've put our bets down and some of our chips are on a mixture of things, but one on hydrogen, and we believe that hydrogen, being the most abundant element in the atmosphere, whether it be contained in water or in other elements, chemicals, but water being clever because of course if you split water you get hydrogen in quantities of 2 and you get oxygen in quantities of 1. So you get a lot of hydrogen opportunity through electrolysis, and we look to harness that by renewable means. If we can get renewable electricity from solar, from wind, from tidal, and use that power to split the water molecules down, we have then hydrogen created in a green form, which is the best way we can get it. There are other ways, but including the grey forms of nuclear, or maybe some blue forms from existing carbon fuels, which might be where the 2% of today's hydrogen comes from. But biofuels is another option. We're looking at sustainable aviation fuels. We've flown an aircraft, this is the Gripen, with the engine that GKN provide into the Swedish version of this aircraft, and also into South Africa. We have a number of these flying in the skies with biofuels being tested in them. You can read more about that on our website. But I wouldn't mind you just pausing for a think, how do we create those biofuels? Well, we have to create things like jatropha, a plant-based, oil-based land mass, which is significant in size for this amount of fuel that we'd need to replace all the commercial aviation with kerosene with a biofuel, and it's also costly. But we have that opportunity to take that into a new era with nuclear, and taking nuclear fusion or nuclear fission if it comes along, and building electrolysis to make hydrogen, and then convert that hydrogen through a process called Fischer-Tropsch also into kerosene as a drop-in fuel. We have the laminar flow of aircraft. We can look at ways and means to try and reduce the drag and therefore the propulsive energy required to pull an aircraft through the skies, and through resistance being released by clever means of inducing a laminarity, which means the proximity of the air flowing over the wing stays attached rather than becomes turbulent. We use different means to do that, and we've trialled with Airbus on a program which has flown a laminar wing section, and that's been seen to be largely successful. But again, to make that affordable and cost efficient for an airline in its maintenance, we have some work to do. we actually perforate the leading edge, and that leading edge quickly becomes clogged up. We want to be able to basically keep that surface clean, and there's some really interesting technologies we're working on to put hydrophobic coatings on metallic surfaces. And hydrophobic coatings mean that you don't get the ingress of damage that might come from bugs and sprays or whatever it might be in the atmosphere, volcanic ash. So that's another way of looking at solving the problem. Another one is the boundary layer. We see the boundary layer on an aircraft really increasing the drag, and with that we can bring new opportunities. If we could ingest that boundary layer back into an engine and take that away, it reduces the stickiness of the overall aircraft, and you can see the boundary layer forming around just a thin plate here and slowing it down. We want to make sure that that boundary layer gets used in some shape or form to better means. And then formation flying, one of my favourites, and this one is a video from the Institute of Mechanical Engineers, our friends not too far from the Institute of Electrical Engineers, where we've been looking at how formation flying could induce, using things like the bird shape of a V, a better way to reduce drag, so that people could fly across a route, let's say from Europe to the US, and in this case each of them benefiting from the lift that's created across the vortices that come out of the lead aircraft, taking most of the energy, absorbing that downwash effectively onto the rest of the aircraft, and performing a more improved drag performance. So aircraft can peel off on their way to America, into New York, to Boston, to Dallas. As we keep crossing over America, we go through into Chicago, and then we're down to the last couple of aircraft that then peel away at Los Angeles and San Francisco. And of course, then you travel on to your final destinations. Maybe that's the way forward, to fly in a different way, reduce the drag, and again, save energy. You will notice that those aircraft are blended wings, and they are being accelerated. We've got some really interesting acceleration opportunities right now. We need to put the energy back into this environment with the COVID situation. We've been working with Boeing at pulling together new facts, new ways of working, new thinking about how we can bring startup companies who are doing really innovative stuff, and we've seen a lot of those now emerging in urban air mobility, which is a form of transport that would fly potentially autonomously, that means without a pilot, and we'd have the opportunity to work together and bring the technologies from aerospace together with those of mobility, whether it be trucks or vehicles, to try and ingest a new axis of travel over and above the road system. You've got many more dimensions that you can play with in an urban environment, and the technology now to do autonomy is certainly picking up a pace, both in the military and now in the UAM or urban air mobility market. And this vision is real. It's going to happen. It could happen within 2 years in Dubai. In less time, if I look at the tea leaves from the military side of things for cargo, and we're already seeing Amazon and others beginning to look towards drones delivering. But more importantly than ever, power and energy conversion is going to be really critical to the future of aviation. If we can't convert efficiently the power, and the gas turbine today is probably about as efficient as it's going to get within 10%, it's still only at about 40% efficiency relative to the cycle that we want to have, and it burns carbon, hydrocarbons, and it creates the environment that we have. And the future of the electric vehicles on the ground mean that this will become a bigger proportion of the burden on greenhouse gases. And not only do we worry about greenhouse gases, but contrails, noxious gases, and nitrous oxide, and we need to think about the overall radiated energy effectively that comes from flying with power systems that we have today, and think about converting those for the future. With that in mind, we took up about the use of data, and we're working with companies who are very innovative in their way, using technology to predict maintenance, but also to predict when to wash an engine, which helps the performance improve. And exciting things like looking at fuel systems in the sky and taking telemetric data to see if you can improve the performance whilst the pilot's flying, giving them some feedback and monitoring their performance, which is kind of Big Brother, but it's adapting. And it could improve the way that we see aircraft being flown and routes that they take and how much they use their auxiliary power unit on the ground and the energy that they store. We could also see the application of Industry 4 very soon. Many of the technologies that we're talking about today will move towards Industry 4 in manufacturing, but also in the environment of safety and the environment of design. What do we mean by Industry 4? We mean, in GKN terms, we're looking at augmented workers, giving the people who are on the shop floor access to more information to make more intelligent and informed decisions. These people could be wearing things like the Microsoft HoloLens, which we used extensively on developing the training material for ventilators. We could be looking at the digital twins. We'll see one of those later in the other room. And we'll be looking at how we can create a digital twin to reinforce simulation and improve the performance of a factory, but also of an operation and an aircraft in the sky. And that allows us to give feedback and make things smarter. And one of those smart ways of manufacturing is additive manufacturing. We're looking at new technologies that can support us there, and we're very keen on building things that have less energy imparted on them and also less waste. Additive manufacturing, unlike subtractive manufacturing, means we can get closer to a net shape and therefore build parts that are much more reliably efficient in terms of carbon and waste that comes with building subtractive machined components. We have a program in the UK called Made Smarter, which we're very much a part of, and we're building out a new factory, effectively a global technology centre, which you're sitting in virtually here today, but this is the building from the outside that you could come and see if you were in the UK. We're looking forward to inviting you. We have other centres around the world, one in Oak Ridge in the US, looking at additive manufacturing, metallic components, transparencies, Bristol, where we've got our big additive capabilities, large scale deposition, integration of that into composites and for thermosets. We also have in Hogeveen thermoplastics and integrated systems for wiring and sensors in Industry 4, and in Sweden we have our Trollhättan facility, which is the core of the knowledge that came from additive manufacturing in space, but it's also welding and machining capable with automation throughout, including some designed capabilities that we don't have elsewhere, aerodynamics, some thermal management, materials technology, and a complete engineering workbench. Our purpose for bringing these things together in the ecosystem that we have is to have a new environment where we can fail fast and learn, excite the potential customers in the market, improve our right first time quality efforts and application to low rate initial production, and technology excellence, really a learning space, training people. And if you want to have one final word of plea for me, think about engineering in its broader sense and enjoy this video and then ask some questions. engineering, and you're part of this community that would like to discover how we can work together over the next hours together, see if we can build a better future, sort out some of these global challenges like sustainable aviation, saving our planet, and I'm really pleased to be here with you today. If you want any more detail about this presentation, here's a little link to the slides that I've given you, and also a little bit more information about how to contact me. But we look forward to taking your questions, and thank you for letting me speak today.